Hello everyone, welcome to lesson 7-8, more factoring of polynomials. This time we are going to factor by pulling out the greatest common factor and by something called grouping. Okay, so whenever you have a polynomial that has 4 terms in it, then one of your best options is to separate them into 2 groups, pull out the greatest common factor from each group, and then simplify your terms. So I am going to go through this first example and show you how that's done. All right, so step number 1 says to separate your polynomials into 2 groups. So if you look right here, we have 3x cubed minus 12x squared, and we took these 2 terms right here, and we just put a parenthesis around them as a binomial, okay? And then 2x minus 8, we did the same thing, okay? So that was step number 1. That's pretty easy. You can do that with all of these problems. Step number 2, determine the GCF of each group of terms. Well, we just did that in our last lesson. Okay, so we have these 2 groups of binomial, 2 groups of terms here. And in looking at this one, we could see that 3x squared is the greatest common factor for this first term, and 2 is the greatest common factor for the second set of parentheses. So how does that work? Well, we pull out the 3x squared from both terms, and we write it on the outside of our parentheses. And when you divide both of these terms by 3x squared, you get x minus 4. All right, then you, so you have that written right here. Then you have the greatest common factor of 2 from the second group. So I'm going to divide both of these by 2. And when I pull out my 2, that goes on the outside, and on the inside of the parentheses is x minus 4. Now at this point, you're going to notice that both of them simplify to x minus 4. Well, our next step is to write out the factored expression for each set of 2 terms and divide each term by the GCF. We did that. And then factor out the common factor. In this case, it's x minus 4. So x minus 4 can be simplified to one set of parentheses, and then your 3x to the second power plus 2 goes to the second one. And then these 2 right here combine to go to that second one, okay? All right, so let's work this out and see what that looks like on our notes, okay? In example 1, we are going to separate our polynomials into 2 groups. So I'm just going to do that right here. I don't even need to rewrite them out. If you want to, you can. In looking at my first set of parentheses, I have a 2x cubed and a 12x squared. Well, I can see that the greatest common factor is going to be 2x squared. If you can't see that, then you need to go back to the way that I taught you how to factor out the greatest common factor and do that. So 2x squared, okay? So I'm going to divide this by a 2x squared, and I'm going to divide this by a 2x squared, and I end up with just an x here, and I end up with just a 6 here. My x squares cancel out, okay? So now when we factor out the second one, hopefully one of that, it will end up with an x plus 6, so we can simplify it, okay? I am going to factor out a 3 from both of these, and I end up with x plus 6 after dividing both of these by 3, because 3 is the greatest common factor. All right, so at this point, x plus 6, that will combine or simplify into one term. And then I have 2x squared and plus 3 that will go into another set of parentheses. So we write it as 2x squared plus 3 times x plus 6. Okay. Now, if you wanted to go back and double check and make sure that you have factored this correctly, you could use FOIL to do that. I'm not going to do that, but you can if you would like. It's always a good thing to do if you're not quite sure that your answer is correct. Okay. All right, let's go ahead, and if you want to try this practice on your own, you can. See if you can do that. The only difference in this one is that you have some subtraction here, so just watch those. Okay, so I'm going to set up my two groups, okay? And in this first group, my greatest common factor is 5x squared, okay? And I'm going to divide these by 5x squared, divided by 5x squared, and I end up with 2x minus 5, okay? And then I'm going to pull out a 2 and divide these both by 2, 2x minus 5, okay? All right, these two can combine because they are the same. If they weren't the same, you wouldn't be able to combine them. And then these two can be combined together. 5x squared plus 2 times 2x minus 5. Okay. All right, all of these examples are the same. The only difference is when you get down to example in practice 3 and example in practice 4, there is a subtraction. You're subtracting the terms in the middle, and so there is a little bit of a difference there, and you'll want to watch how I do that. Other than that, you should be able to do example in practice 2 on your own. Oh, I'm sorry, these are a little bit different. Okay, sorry about that. I'm going to divide both of these by 5x squared. So I end up with 5x squared, 3x plus 8. And then if you look at the second term, it already is a 3x plus 8, and you really can't factor that. So we say that we're going to factor a 1 out of it so that we have two binomials, which is your goal. So I'm going to factor a 1. Well, 3x divided by 1 and 8 divided by 1 is just 3x plus 8. Okay, so then when you end up with the situation like this, now you'll have two binomials, 3x plus 8 and 5x squared plus 1. Okay, now a lot of you are just going to write 5x squared without that plus 1, and it would be wrong, because when you FOIL it back or you distribute it back, it will not equal what we started out with, and that is your goal when you check your answer, is to make sure that when you FOIL it or you distribute it, that you end up with what you started at. Okay. All right, so this one's going to be very similar. You can already see we're not going to be able to factor anything out of that second term, but a 1, okay? Out of this first one, I am going to factor out a 2x squared, okay? So 2x squared, 7x plus 4. And then we're going to pull out a 1, and we're still left with 7x plus 4. Okay? So now we have 2x squared plus 1 times 7x plus 4. Okay. All right, so now we get to move on to subtraction, where the two sets will be separated by a subtraction sign. So let me show you what I'm talking about here. When I set these up into two groups, notice that this is subtraction instead of addition. So that means that when you factor out of this, you are going to factor out a negative common factor, not a positive. And then I'll show you how that works. Okay, so for this first one, we're going to factor out a 2x squared. Okay. And we'll be left with an x and a 6. Okay. All right, on this second one, I can factor out a 6 from the 6x and a 6 from the 30. So I'm going to pull out, I'm going to pull out, yes, a -6. Okay, so I'm going to pull out a -6. Now, when I divide this, I now have a -6 divided by a -6, which is going to give me an x, and a 30 divided by a -6, which is going to give me a +5. Oh, did something happen? Is that 5? I think I covered it up. It's a 5, guys. I'm so sorry. When I put my parenthesis around it, I made it, it looks like a 6 because I can't see it. So I'm pulling out a -5, not a -6. Like, that doesn't match. That's not right. So -5 divided by -5 is a +x. -30 divided by -5 is a +6. Now, some of you may be asking, why are you counting this as a negative? Well, because the negative is in front of it. And so I count it as a negative. Okay. All right, so now we have 2x squared minus 5. And x plus 6. Okay, and there's our final answer. Okay. These next 3 are very similar. If you'd like to try these out on your own and then check your answer if you get it. If you're still having a little bit of trouble or not quite sure, then just follow along as I do this one and then maybe try these 2. Okay. All right, so in these 2 terms, I can only pull out a variable. So I'm going to divide both by x squared. Okay. And so I end up with 2x minus 5. Okay. And then here, since this is a negative, I'm going to pull out a negative greatest common factor of 3. So minus 3. So -6 divided by -3 is a 2x. -6x divided by -3. And -15 divided by -3, a +15 divided by -3 is a -5. Okay, so I have x squared minus 3 times 2x minus 5. Okay. You can go ahead and start on the bottom 2 if you would like, just to see if you have the right idea. I'm just checking over my answers, make sure they're correct. Okay, I'm going to start on this one. Okay. For this one, I'm going to take out a 9x squared. And on this one, I'm going to take out a -2. No. I'm going to take out a -4. That was weird. -4, -4, -4. 2x plus 5. There we go. So now I have a 9x squared minus 4 and a 2x plus 5. Let's do this last one. And 4x squared on both of them. Now I do want to show you something, and then a -3 over here. I do want to show you something. A lot of you were not putting anything for something like 4x squared divided by 4x squared, but that actually equals 1. So you have to include that as part of your answer. Okay. So 12 divided by 4 is 3. X cubed divided by x squared is x. And then 4x squared divided by 4x squared is just 1. And I pulled out a -3 from the second set, and I get 3x plus 1. So I have 4x squared minus 3 and 3x plus 1. Okay, so that is factoring polynomials by grouping, part 1. Now we're going to move on to the second page, where we have one additional step. Sometimes you can factor out the greatest common factor first and then group them. So if you notice that your polynomial has a common factor among all 4 terms, factor that out first, then set up your grouping. Notice on all the ones we did here that they didn't have a common factor. Not all 4 of them did anyway. So we couldn't factor out the greatest common factor first. This does get a little bit tricky. There are more steps and you have to make sure you do them correctly. So please watch through 3 or 4 of them and then try them on your own. Even when you get down here, there's trinomials and we have to do something a little bit different on those. Okay. So in looking at example 5 and step 1 up here, I'm going to factor out a greatest common factor from all 4 of those, which is going to be 4x. Okay. Now, if you were going to factor this out yourself, and for those of you who can factor without doing this, you can skip this part, but for those of you who need help with factoring, I have 4x to the 4th, and that factors out to 2 times 2, and then 4 x's. Then I have -8x to the 3rd, which factors out to 2 times 2 times 2, and then 3 x's. And one of these 2's could be negative. Okay, we'll wait and look at this. Then I have 12x squared, which is 2 times 2 times 3, and then 2 x's. And then we have -24x, which is 2 times 2 times 2 times 3 times x. And then at this point, we circle all of our common factors among all 4 terms. Okay, so I have all 4 have a 2 here, all 4 have a 2 here. Not all 4 have a 3 or a third 2, but all 4 do have another x. So my greatest common factor is 2 times 2 times x, which is 4x. And then I would take each of these terms and divide by 4x, or if you do it this way, you can just count up what's left. I have x cubed, I have 2x squared, I have 3x, and I have 6. So when I write out my factored out polynomial, 4x, my greatest common factor, goes on the outside, and then I just write these in with the same operation that was originally in, or that was in the original polynomial. So I have x cubed, which was positive, and then I have a minus 2x squared, then I have a plus 3x, and then I have a minus 6. And there I have factored this out doing the long method of prime factorization and all that. Okay, and you would do this if you cannot pull out the greatest common factor by looking at it. Okay, all right, so now I'm going to go up and do it the shortened version. So my greatest common factor is 4x, so I'm going to divide everything by 4x. Okay, and I end up with 4x and then x cubed minus 2x squared plus 3x minus 6. And that was where we left off just a minute ago. Now what I'm going to do is I am going to, once we factor out the greatest common factor, we just follow the steps that we had on the previous page, and we are going to separate them into two groups. So I have one group here, and I have one group here. And now I'm going to factor out the greatest common factor. Now, when you do this, you cannot ever forget this 4x. That's really important. So in looking at these two right here, when I find the greatest common factor and divide them, okay, it's x squared, by the way. And over here, it's going to be 3, okay. Then what I will do is I will write my 4x over here to the side, okay. And then I have x squared was my greatest common factor, and then I'm left with x minus 2, okay? So if you ignore this, this is actually what we just did. So if you did fine on the previous page, we just added that one initial step, pulling out the greatest common factor first. Okay, here I have plus, and I pulled out a 3, and I'm left with x minus 2. And so this leads us to our final step in writing out our two binomials. So these two are the same, so we can simplify that to one group. And then you have this and this. But again, we cannot forget the 4x. So this is what we do. We write 4x, and then x squared plus 3, and then x minus 2. Okay, so that is our final answer right there. So definitely one additional step than what we had before. This is a lot of factoring. It's really important though. Okay, all right, so let's start with practice number 5. In number 5, we can pull out, looks like a 4. Yes, a 4. And so, yeah, just a 4. We can't even pull out any variables because this last term doesn't have any variables. So I'm going to pull out a 4. And just divide everything by 4, all the coefficients. Okay, so I have 4, and then 2x cubed minus 8x squared plus 7x minus 20, is that right? 28, 9, 10, 11, 24, 28. Is that right? Yeah, 28. Okay, now I'm going to, our polynomial has 4 or more terms, so I'm going to group them and factor them. So I'm going to group it into this and into this. Okay, so the greatest common factor here is going to be 2x squared. And the greatest common factor here is going to be 7. Okay. Can't forget our factor that we pulled out from the first step, 4. And then we have 2x squared. So 2x cubed divided by 2x squared is x. And 8x squared divided by 2x squared is 4. Here we pulled out a 7. 7x divided by 7 is x. And negative 28 divided by 7 is a negative 4. Okay, so we have our initial greatest common factor, then we have these two that we pulled out, and then we have these two that we can simplify. So for 2x squared plus 7 and x minus 4. All right, If you feel confident in trying these on your own, you can. If you want to watch one more and then do this practice one, you can. The difference though between this practice number 6 is that it is subtraction. So the greatest common factor you will be pulling out from the second set will be a negative. So just keep that in mind. Okay, the greatest common factor here is going to be 5x. Okay, so we have 5x. Okay, I'm going to separate them into my two groups. And I'm going to divide both of these by x squared. That's the greatest common factor. And both of those by 4. Okay, so these two will come together and these two will simplify down to 1. And we will have 5x, x squared plus 4, and x minus 1. Okay. All right, let's go ahead and look at example 6. Okay, the greatest common factor I'm going to pull out of all of these will be the 3x. Okay. So 6 divided by 3 is 2. X to the 4th divided by x is x cubed. 3x cubed divided by 3x is just x squared. Negative 24x squared divided by 3 is a negative 8x. And negative 12x divided by 3x is a negative 4. Okay. Separate these into two groups. And out of this one, I'm going to pull out an x squared. And out of this one, I'm going to pull out a negative 4. Okay. So we have 3x, and then we have x squared. And that will give us a 2x plus 1. I lost my train of thought there for a minute. And then a minus 4. And then negative 8x divided by negative 4 is a positive 2x. And then negative 4 divided by negative 4, positive 1. Okay. All right, let's put this together. 3x okay. Now, if you're having trouble with this, I would definitely come to help class this week or next week. Okay, now we're going into trinomials instead of polynomials. So it is a little bit different. We're going to have to go back to the X and box method, possibly, or just the X method, depending on what our greatest common factor is. All right, so let's look at this. We can divide all of these by 9. And I know you don't think 144 is divisible by 9, but I've done it. Okay, so and we can pull out an X. So I'm going to divide everything by a 9x. Okay. When we do that, we're left with x squared minus 10x plus 9 goes into the 14 one time with 54 left over. So that'd be 16. I make sure I'm right. I am right. I couldn't find it. Okay, so now we're left with a trinomial, And hopefully you guys remember this, but this topic is going by so fast. But I'm going to use that little x, if you remember that. And I am going to try to factor 16 times 1 is 16, and then the middle term negative 10. So what I'm going to do is try to find factors that multiply to get 6, but add to get negative 10. So I have, 2 and 8 maybe? Negative 2 and negative 8. Negative 2 times negative 8 is 16. Negative 2 plus negative 8 is negative 10. So here I have it. So then I don't have to do the box method because our leading coefficient is 1. So I cannot forget the 9x. And then I have x minus 2 and x minus 8. Okay, and that's my answer. It's a little bit less work even than up here, I think. Maybe not, I don't know. Okay, I was supposed to do that in pink. Okay, and the next one's just like it. So let's try that one. Okay, the greatest common factor is going to be 4x. Okay, so let's pull that out. We're left with x squared plus 13x plus 40. Okay, now I'm going to do my x here, and 40 times 1 is 40, and then 13 goes in the middle. All right, so I'm looking at this, and I know 5 times 8 is 40, and 5 plus 8 is 13. So can't forget the 4x we factored out, and then we have x plus 5 and x plus 8. And there we have it. Okay. All right, let's look at this one. Okay, on this one, the only thing that I can pull out is an x. Everything else has to stay. So we're going to divide everything by an x. And then that means our leading coefficient is no longer 1, and we will have to use the box. Okay, so let's do that. Okay, 15 times 6 is 90. And then we have 19. All right, this isn't so bad, right? We have 9 and 10. 9 times 10 is 90. 9 plus 10 is 19. Okay, so we don't want to go straight into writing it like we did up here, because that when we checked it and foiled it, it wouldn't go back to looking like what we started with. So don't forget that if your leading coefficient is not 1, you have to also do the box. So I'm going to do the box. Okay, we have 6 and 15, and then we have 9 and 10. Okay, so I wanted to start with 2 and 3, but I noticed that nothing times 3 is going to give me 10. So I'm going to go with 3 and 2. 3 times 2 is 6. 3 times 3 is 9. So what times 2 gives me 10? 5. And then 5 times 3 gives me 15. So now I have my 2 binomials. And so what I'm going to do here is I can't forget this x. We have x on the outside, and then 3x plus 5 from the top of our box, and 2x plus 3 from the bottom of our box. Great. So the next one's going to be very similar. And there you have it. I didn't talk much on that last problem just because I think we've done this so much that I think most of you are going to be okay with it. If you have any questions, please let me know. This isn't the last unit in the topic, so I'm not sure if I will be assigning the last 2 lessons or not. But please come to help class if you have any questions, because these concepts aren't necessarily easy and there's a lot of steps and you can mess up with, pretty easily with some of these steps. So I will see you guys all at our next class if you come.